Today we are discussing about a series and a parallel connection of resistor. Let's continue. Before that, subscribe, share and like our videos. First, let's define what circuit is. A circuit is any closed path along which current flows. It is any closed path along which current flows. And we have two kinds of circuit: a series circuit and a parallel circuit. A series circuit and the second one a parallel circuit. Or we may have both series and a parallel connection together. Now let's see a series connection of a resistor. When we mean a series, it is a connection of two or more resistors along one path, which means current flows along one path, and the second one a parallel connection, which means a branched circuit. For a parallel connection of resistor, current has more than two paths since it is a branched circuit. Parallel connection, let it be R1, R2 and R3. This is a parallel connection of resistors. Current from the source branched when it reaches at this point. It can pass through R1, it can pass through R2, it can pass through R3. Then it has more than two paths. For a series connection of resistors, R1, R2 and here is R3, they are connected along one path. Current flows only in one path. And let's see a series connection in detail. Series connection of resistor. Connection of resistors. For a series connection of resistors, current from the source is the same throughout or across each resistor. Current from the source is the same, which means I total equals current across resistor 1 equals current across resistor 2 equals current across resistor 3. If we have n number of resistors, the current across each resistor is the same. And for a parallel connection, for a series connection, total voltage is the sum of the voltage across each resistor, which means the voltage total equals voltage across resistor 1 plus voltage across resistor 2 plus voltage across resistor 3. If we have n number of resistor, voltage across each resistor, this the sum of the voltage across each resistor is equal to the total voltage. For a series connection of resistor, to find the total resistance, let's take the voltage equation from total voltage equals V1 plus V2 plus V3 plus Vn, and from Ohm's law, voltage means from Ohm's law, voltage is equal to resistance multiplied by current I. Current I is equal to voltage over resistance, and resistance equal to voltage over current I. Then from Ohm's law, total voltage means total resistance times total current, R total I total equals R1 I1 plus R2 I2 plus R3 I3 plus Rn IN. But current is the same, so we can factorize I into R1 plus R2 plus R3 plus Rn. This equals R total I total, and divide both sides of the current, both sides of the equation by current I, divide by I cancel I cancel I. Then the total resistance for a series connection equals R1 plus R2 plus R3 plus Rn. Then we can say the total resistance or the effective resistance for a series connection, of resistors is the sum of resistance across each resistor. Now let's see the second classification of a circuit, which is a parallel connection. For a parallel connection, voltage in each circuit for a parallel connection R1, R2, and R3. Then there is a source of a potential difference or voltage. For a parallel connection, voltage total is the same as the voltage across each resistor. Voltage is the same throughout the circuit. Voltage is the same, which means total voltage equals V1 plus, V2 equals V3. If we have n number of resistors, the voltage across each resistor equals the total voltage. But current is the sum of the current across each resistor. Total current is the sum. Current sum, voltage the same for a parallel connection of resistor. which means total current I total equals I1 plus I2 plus I3 plus IN, and current from Ohm's law, voltage over resistance total equals V1 R1 plus V2 over R2 plus V3 over R3 plus Vn over Rn. And voltage is the same, so we can factorize total voltage over R total, or equivalent resistance, or the effective resistance for a parallel connection equals V into 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over Rn. And voltage the same throughout the circuit, so we can cancel out by multiplying by the reciprocal of the voltage. We get 1 over R total, or 1 over R equivalent, equals 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over Rn. This is to find the effective or the total resistance for a parallel connection. Since it is the reciprocal, the total resistance or the effective resistance, the total or the effective resistance for a parallel connection is less than the individual. And if we have two resistors that are connected in a parallel, the equivalent resistance can be solved. R equivalent or R total equals R1 plus R1 times R2 over R1 plus R2. This is as an activity for you why this comes. The total or the equivalent resistance equals R1 times R2 over R1 plus R2. This is the end for today. Next we'll see Kirchhoff's law.